Good evening, everyone.
Good evening, sir.
Yeah, good evening, everyone.
Good evening, sir. Good evening, sir.
Yeah, good evening, everyone.
Good evening, sir.
Yeah, good evening. Good evening, good evening. So in the last class, we have done the chapter units and measurements. So, so okay, hold for just 1 minute. Today we'll be doing a bio chapter. Okay.
Sir, sorry, sir. Sir, I got what you said, sir. We are going to do today.
Yes. आपसे मिस साइड हो इस साइड से गैलरी में चले जाओ
Sir, today we are going to do a bio
Okay,
chapter.
so are you able to see this? Yeah, today we are starting with bio chapter. Okay. Okay, so today we'll be doing a chapter from bio, right? And okay, so how many chapters have you done from bio?
Sir, only one, sir. We are still doing that. I guess you complete.
Okay, you are,
Sir, can you change your
so when has the last
microorganisms?
uh, microorganisms? So when was the last class of?
Last Thursday. Jyotisha ma'am was on leave, so Manisha ma'am have been taking.
Okay, so actually is taking the classes, right?
Sorry, sir.
Yeah, ma'am is taking your classes.
Actually we have last Saturday the class, sir, but last Thursday ma'am took as ma'am has been leave on the last Saturday.
Okay,
Ma'am
and
took
what
on
about?
Thursday. Sir, can you change your
Okay,
keys to
so
black?
and what about your chemistry syllabus?
So
In chemistry, how
chemistry
much?
we were doing combustion and flame.
Okay, okay, let's continue with that
Sir,
combustion and flame.
Pranava is calling,
First,
sir.
I'll ask ma'am, and then yeah,
Pranava is calling, sir.
yes, Pranav.
Sir, can you change your theme into black one?
Yes, Pranav. Which one?
Black.
Black. Which black?
The screen, yes, sir.
Yeah, this is
The
this one.
board, sir. The board. Yes, sir. Yes, sir. Same.
So let's have. Now, in the last chapter, we started with combustion and flame in chemistry. We had defined combustion. Can anyone redefine combustion for me?
Combustion. The combustion is the process of
Yes.
reacting with oxygen to burn itself.
It's the reaction of
Very
oxygen.
good, very good. The process of reaction with oxygen. Yes, yes. Yes, continue. It is the process of reaction with oxygen. It is the process of reaction with oxygen to produce heat and light. And in the last class, we had seen some combustible and non-combustible substances. So what are combustible and non-combustible substances?
Combustible substances are which,
substances
sir,
are
sir, I want to say,
Then which can produce heat and
sir,
light. Combustible.
combustible, which is luminous, and also there are no end products, and non-combustion are in which they won't be combustible and they have end products.
Okay, no, that is certainly not we say as combustible and non-combustible. Anything
Like,
which can be burnt,
yes, sir. Like
anything which
coal
can be
can
burnt
be
is combustible.
coal
Yes,
is
coal can be burnt, plastic
coal
can
can
be
be,
burnt, wood
but
can be
it
burnt.
is but coal is a non-combustible.
dry leaves can
Coal is a non-combustible substance.
Coal is combustible. It is a combustible substance.
So, but
Combustible
when we
means
burn
the substances which can burn.
sir, but
Yes.
we will be getting the coal won't be burnt so completely, right, sir? If we are cooking with the wood, there will be the wood. If we burn the wood, there will be
Residue
remain.
left after which we call as ash.
Yes, sir. Ash will
Yeah,
be
there.
left out, but in LPG gas stove, there is
Okay, so
nothing if we burn.
okay. You are getting mixed with clean fuel. That was for what we were talking of, clean fuel. Right? Clean fuel are the substances. Clean fuel is a fuel which does not leave any residue. For example, if you talk of petrol, so petrol burns without leaving any residue, it is a clean fuel. CNG is a clean fuel. LPG is a clean fuel as it does not leave any residue after burning. Okay? So those are the clean fuels. Okay, Pranava, very good. Pranava, very good, even if you understand. Okay, everywhere we will try to get a new concepts. Okay, Pranava? Okay, we will get something new. See. So after this, we had done the clean fuel, we had done characteristics of a clean fuel, and we had also done about the ignition temperature. Now, what are the conditions necessary for combustion to take place?
Oxygen.
Sir, ignition temperature, sir. Ignition temperature.
Okay,
Sir, oxygen.
oxygen, very good. Anything else?
Sir, combustible substance, sir.
Yeah, there should be a presence of combustible substance. So you should have here the presence of a combustible substance. There should be presence of combustible substance.
Presence of oxygen.
There should be ignition temperature.
Ignition temperature is nothing but the room temperature, right, sir?
The point at which it burns.
Sir,
So presence of combustible substance. You have presence of oxygen.
sir, I have a doubt.
Right. Yes.
Sir, ignition temperature means room temperature only, sir.
Ignition temperature means minimum temperature at which the fuel catches fire. The minimum temperature which should be reached for a fuel to catch fire, that we call as the ignition temperature.
Okay, sir.
So all
Thank
these
you,
are the necessary conditions for combustion to take place. Now today we will discuss about the flame. How a flame is produced, what are the different regions of the flame.
Sir,
Okay. So how a
Sir,
flame
can
is
you go into
produced?
the before slide once?
sir, outermost zone of flame, innermost zone of flame, and middlemost zone of flame, sir.
Okay, any other names for those zones?
Huh?
About their temperatures?
about like candles, sir. Sir, I got your question. Could you repeat again?
Yes, last year, what are you saying?
Sir,
Yes.
the question, could you repeat again?
What's your question last year?
Sir, you just gave a question, right? So your voice was breaking. I had a network issue, so it's raining. So the question, what you repeated, could you repeat again?
Sir?
Yes, my question was, what is a
Sir,
flame?
can you go to the before slide once? I mean the last point.
Yes, sir.
Sir, I have doubt, sir.
Yes.
There is exam this Friday, tomorrow, right, sir?
Okay.
Yeah, sir.
Yeah.
So, like, what topics of friction will be on it, sir?
Everything from friction, everything.
Okay, sir. So, if I read the NCERT textbook, it will be sufficient, sir?
Yeah, it will be sufficient, but maybe you will just go through the notes which have been sent also.
Sir, did you send the notes, sir?
Yeah, notes are available on the WeXL
Okay, sir. Thank you.
over there
Because,
after the
sir,
class.
it's different from the syllabus that I study, so I just want to double check.
Now let's see here. We now to discuss what is a flame. So flame is a region. Pranav, can you tell what is a flame?
Sir,
What is a flame?
sir, sir, which is the substance is burnt.
Which substance burns? No. See,
Sir,
flame, it
gases,
is
gases.
gases burn. It is the region where gases burn.
Flame.
So, yeah, the
The
region where gas.
substances which the substance which evaporize during burning give flame.
Yeah, and the substances which do not evaporate during burning, they do not give a flame.
Like
Right.
example, kerosene oil and molten wax.
Yeah, kerosene, wax. So all of them, they evaporate on burning. Right. So they evaporate on burning to produce the flame. So now the region where the gases are burning, that region we call as the flame. Let us see first a candle flame and the regions of the candle flame that we can discuss.
Sir, where is it, sir? I cannot find it.
In the case of candle, which gas is burnt, sir?
Yeah, Pranava, can you pardon? Can you repeat?
Sir, we are saying that it is the region where gas is burnt. In the case of candle, which gas burns, sir? There.
Candle?
In the case of candle, which gas burns?
Okay, which gas burns? Okay. You specifically can't see, can't call a specific gas. Like as candle is a mixture of a number of compounds. Okay, a number of compounds are mixed up together in candle. So if you just think of like petrol, and if you want to know that yes, what chemical is petrol actually? So petrol is a mixture of a number of chemicals. Okay, each chemical has about a chain of 40 carbon atoms. Okay. For a diesel, the number of carbon atoms is around 60. Or not 60, it's about 90. Okay, so it is a mixture of compounds. It's not just a single compound. In the same way, your candle wax is also a mixture of compounds. It's not just one compound. So you can't say that just one gas is coming. There are mixture of gases which are there, which are generally alkanes. We'll discuss more about them. So the gases which evaporate over here, they start burning. Yes, Pranava, any doubt?
Sir, like I want to know more.
Okay, you wanted to know which gases are there, right?
Like you have said, another concept called alkali.
Yes.
When we burn a agarbatti like inside stick or any candle, we will be getting the black color flame. Like first the black color smoke type, the black color smoke type will be getting, right, sir? That is carbon dioxide.
No, the black color smoke which you get, it's not carbon dioxide, it's carbon.
Okay. Like if we place a
See,
paper on,
now here you have,
if we
yes,
place
what
a
happened?
paper, yes sir. If we place a paper, when if we just burn a candle, if we place a paper on that, the carbon will be coming on like
Deposited.
it
Yeah,
gets
carbon will get deposited over there.
okay sir. If it won't burn, sir, the paper won't burn, right?
Yeah, the paper won't burn. If the ignition temperature of the paper increases, and if the temperature of the paper increases, since it is near a flame, right?
Yes sir.
So if it is near a flame and if its temperature increases to ignition temperature, then only the paper will burn. Otherwise, the
Okay.
paper won't burn.
Yes, sir. I actually did a combustion and flame regarding this chapter experiment, sir. When
Yeah.
I just burned the candle, it was very the wax, the wick was very inside, and I placed a plastic box on it. And when I just left it for a few seconds or 1 minute, I just left it like that. The plastic started burning. It
Yeah.
started melting. And when I
Yeah.
just took a stick like that and
Start
when I poked
melting
it,
because the temperature of plastic.
yes, sir, from inside it got melted because of the smoke flame. The wick was very inside, but the heat is very high. If keeping the hand very high from the wick, also the hand is just burning.
Okay. See what happens. We are going to study here the regions of the flame. Okay. So the regions of the flame which are we are observed, you can see the outermost region is blue in color. Then the middle layer, it is about orange in color, or you can say red in color. So it's orangish red in color.
Sir, is
And
the blue layer is where total combustion occurs, right, sir?
yeah, and the innermost layer, it is called as the dark zone. Here, no combustion takes place. In the innermost, no
Sir, is
combustion
this a
takes
part
place.
of our syllabus?
Sir,
Yeah.
no combustion takes place in the dark part, no, sir?
What happened?
Sir, low combustion takes place in the dark zone, no, sir?
Sir, is this a part
Yeah,
of our
no.
syllabus?
Yeah, it is in the part of syllabus. So no combustion takes place in the innermost zone or in the dark zone. No combustion takes place here. Okay. What happens here in the innermost zone? You only find the vapors of the gas at a high temperature. So the temperature of the dark zone is about 800 degrees centigrade. Okay, it's about 800 degrees. Then the next temperature is of this orange or red flame. And after that, the highest temperature is of the blue flame, which is about 1200 degree to 1400 degree. Okay. The middle zone has a temperature of around 800 to 1200, a medium between. Okay. So can you think why the blue zone or the outermost zone has the highest temperature?
Sir, because it is
Sir, because there is
more
more
exposed
combustion.
to the oxygen.
Because there is,
Sir, because it is more exposed to the oxygen.
yeah, they are exposed to the most of the oxygen. See, all the gases, when all the gases evaporate out from here, so in the surroundings you have oxygen. Now oxygen has to interact or react with it. So when this is the outermost zone is the zone which obtains the maximum amount of oxygen. So maximum combustion takes place in the outermost zone. Okay, I'll tell you one trick over here. You can try to use it at your home. Okay, so the outermost zone is the hottest one. Then this red colored zone, which you observe, it is also called as the luminous zone. Orange or red zone, it is the luminous zone. It is the only zone which is producing light. Okay, the blue zone is not producing light. It's very hot. So here light is produced very less by the blue zone. Just like, see, at your home, you also observe the burning of the gas stove. What is the color of that flame?
Blue, sir.
Blue and orange, sir.
Blue, not orange. If you are getting orange, so there is some problem with your stove. Okay,
Sir,
you
I
must be
think the
getting your
orange, sir. I got bluish orange, sir. Like some blue, some orange, sir.
no, you will be getting complete blue flame. If you are getting somewhere a little bit of orange flame, so your oxygen is not getting up mixed up well with your flame, with the stove. You need to get your stove checked. Okay, and you are not able to utilize the complete flame.
Sir, the red color flame will come also when the gas of the cylinder is also upright, sir. Yeah.
Yeah,
Sir,
what happened?
sir, what I was saying was that the red color flame will show when there is no more gas left in the cylinder.
Uh, yeah, that situation can also happen. That will happen when the pressure inside the gas reduces to very less. So then you will observe it. Okay. But yes,
Okay.
in most of the cases, you will be getting your blue flame. So the blue flame, when your gas burns, so do you observe a lot of light in your kitchen with that flame? No,
No, sir, not at all.
No,
Not
sir.
there is there is no light at all.
Gas we get, sir. It LPG gas.
Yeah, even when you are burning the LPG gas, but if you are getting a blue flame, so that will be non-luminous.
Yes,
This is a
sir.
non-luminous. This is
Yes,
not
sir.
bright. Okay, it is not going to create any light in it. It's just causing the heat. So when you want the heat, you need your blue flame. When you want the light, you need the luminous zone, you need the orange or red zone. That is the middle layer. This is the middle layer. Then the dark zone, which has a temperature of nearly 800 degrees centigrade, and it has a it has a large amount of gas vapors present over here in the. Okay, now suppose I want to burn a candle. So I want to burn let's say a piece of matchstick which is burnt already, a little bit of burnt matchstick, that means it does not have that phosphorus coating on it, and I want to burn it. So there are either I can just put the matchstick up to this distance, I can take the matchstick up to the middle zone, or I can take the matchstick up to the innermost zone. So where do you think will it catch fire easily?
Outer zone, sir.
outer zone.
Outermost zone. Okay, so here if you just bring it near the outermost zone, it will catch fire as it has the highest temperature. Right. Now my question is,
Sir.
why do yes,
So, but during where we have diyas, right, during the Diwali time. So
yes,
when we
during your
try to fire the firecrackers, but sometimes it does not get fired up, like burned up. Yes, sir. The
Easily.
crackers. Yes, sir. When we keep the what we say that near
When
the
we keep
candle,
it
that
near, sir, it does not burn.
that stick, sir. The cracker stick. When we keep near the candle, it won't catches the fire so fast.
yeah,
It takes a lot of time.
no. I think you are doing the experiment in a wrong way. Okay. Just 1 minute. I'll show you how to burn those crackers. Just 1 minute. Just 1 minute. Give me some. Okay. Yeah. So if you are talking of these crackers, okay, so you just need to place it a little bit close to the fire, a little bit close to the fire, so it will start catch the fire. You need to hold it over there for some time, okay. And if you place it inside the fire, so definitely this is sufficiently thick so that it's just for 1 minute. Yes, what happened, Pranava?
Sir, I have a doubt, sir.
Yes, what happened?
Like how the associativity with oxygen produces fire, sir.
Just
Like
repeat
how
again.
do, how does the association with oxygen produces fire, sir? Like how?
Yeah, like how it produces fire. That is what you want to know.
Yes, sir. Like with
Okay,
other gases, it won't burn, no, sir. Why?
okay. See, the two very important elements of the chemistry, we discuss about mainly hydrogen and oxygen. Okay, these are the two very important chemicals. Okay, so now what happens? Whatever substances react with hydrogen, they are generally supposed to form hydrides. And if a substance react with oxygen, it's called as oxide. Now see, in our atmosphere, which are the gases that are present?
Nitrogen.
Yes, nitrogen. What is the percentage of nitrogen?
78%.
78%.
8%.
And what is the percentage of oxygen?
21.
21%.
21%. Okay. What are the other gases which are present?
1%.
In 1%,
0.01.
you have carbon dioxide, you have helium, you have neon, you have water vapors.
Argon.
All these gases, they are present in that 1%, right? Now see, nitrogen is almost an inert gas. This is almost inert.
Like nitrogen won't react with any element in periodic table.
Yeah, it reacts. It reacts. It doesn't mean it doesn't react. Nitrogen reacts. But almost inert means that it doesn't react so much.
Okay, okay.
Okay. If you try to react nitrogen with carbon, so it's almost inert. Okay. So the only element that is left out is your oxygen. And oxygen is highly reactive. This is highly reactive element. So when oxygen reacts with any of the elements, it is an exothermic process. It releases heat. If oxygen reacts with carbon, so it releases heat. And this process is an exothermic process. Heat and light is produced. If oxygen reacts with hydrogen also, then also it releases heat and light. And that is what we are interested in. In this chapter, we are interested with heat and light. We are interested with how much is the heat generated, how much is the light generated. Got it?
Yes, sir.
Okay. So any other doubts? Okay, now just last point from this topic. Which are the substances? Okay, or you can say why coal doesn't produce a flame? Why coal doesn't produce flame?
Because it
Because of
releases carbon
carbon.
dioxide. It
So
releases
what?
over carbon.
It releases
Over carbon, sir. It like
over carbon. No.
yeah, like if we add some water, the flame comes out, but for a few seconds only it will be.
No.
It has carbon dioxide, carbon monoxide.
No. Anyone? Pranava, can you think of why coal doesn't produce flame?
Sir, because of carbon.
No. Gautam?
Yes, sir.
Yeah. Okay. Okay. Lasya? Why coal doesn't produce a flame?
Oh yes, sir. Sir, because it doesn't turn into vapor.
Okay. Yes, that's the correct answer. Because it doesn't form vapors. Okay. Or it doesn't turn into a gas. So it doesn't form vapors. Carbon dioxide or coal, it doesn't vaporize, So that is why it doesn't form a flame. Got it? So
Yes,
only
sir.
those substances which vaporize, they form a flame. Also, they need sufficient amount of oxygen for their combustion. If there is incomplete combustion, so you will observe black smoky flame observed. If you are observing a sooty flame, if you observe some dark particles which are being released from the flame, it indicates that your combustion is incomplete. Right? Okay.
Yes, sir.
Anyone else having any other doubt?
No, sir.
Sir,
Yes, sir.
even
Yeah, what happened?
Is there argon in our gas around us?
Yeah, argon is there, but it's very less amounts.
Sir?
It
Sir,
is
argon is only
present in very less amount.
0.03. Sir, argon is only
Very less.
0.03%, sir.
Yeah, very less amount argon is present around us, and it is also inert.
sir,
Okay,
breathing a lot of carbon dioxide causes to death, sir.
yeah, what
Like,
happened?
sir, like the situation, what happens if I don't understand this topic, sir. When we close all the doors and windows, and when we burn the coal, and when we will be asleep, we'll be causing to death by teachers told, sir. But I didn't understand how it burns.
One sir.
Your voice was breaking in between, so I didn't get your question. Can you repeat it? Just a bit. Take your time and repeat it quietly.
Yes,
Repeat
sir.
it.
Sir, am I audible?
Yes.
Yes, sir. My teachers told that, like my chemistry teacher told me that when we
Yes.
close all the doors and windows, the room is closed, and when
Yeah.
we burn coal and we
Yeah.
will be sleeping, it is
Yeah.
dangerous. The teachers told, sir, but I
Yeah.
didn't
Yeah. Yeah.
understand.
Yeah.
Sir, I
Yeah.
know.
It is very dangerous. See, and even it has caused death of many people. If you are
Because
burning coal, if you are burning coal in your room, if you are burning coal in your room and over there you are sleeping. So generally not here, but in Western countries, people earlier used to do this. In India also, in Jammu and Srinagar, people used to do this. In their
Yes, sir.
home, they used to lit fire because of the excessive cold and harsh conditions. So
Yes,
they
sir.
used to burn coal in their room. So what will happen if you are burning coal? So this is your room and you start burning coal somewhere here. So this coal will start consuming the oxygen present in your room, and
Yes, sir.
it will release carbon dioxide, and then later on it will also release carbon monoxide. All the oxygen level which is there, it is decreasing. There is less amount of oxygen. Okay,
Yes.
as it keeps on burning, oxygen level decreases. So when you are sleeping, you won't be aware, and you will start inhaling carbon monoxide. There will not be any oxygen available to you, so you will die down. So it has caused.
What is the
This is
outside,
why
sir?
they have the chimneys, sir, in the Western countries.
Yeah, that's why they have chimneys. Got it?
Sir,
Okay.
even
Yeah,
carbon monoxide is dangerous than carbon dioxide, sir.
yeah, carbon monoxide is too dangerous. It's very dangerous than carbon dioxide. All right.
Sir, will the
Yes.
percent of these gases will be same, sir? Like oxygen will be 21% in the air, or will it will be decreasing?
Due to recycling process, oxygen process continues to remain the same. Okay, due to the recycling process. Yeah, due to photosynthesis, it almost remains the same. Got it? Okay, bye. Bye, all of you. Okay, bye.
Bye, sir. Thank you, sir.